Hello friends, today's topic is finding polar coordinates from Cartesian coordinates using TI-84. Before going into details of this topic, I just want to briefly brush upon the complex numbers. This is basically related to complex numbers. So complex number could be represented as a plus bj, where the first part is your real part and the second part is your imaginary part. For instance, if we have a number like 2 minus 3j, this is in Cartesian form. So if we have to find the polar form, what we have to do is for the polar form you have the magnitude and then you have the angle with it. This is your polar form. So this the magnitude is basically the square of a plus the square of b and square root of the whole thing. So that's gonna be 2 square plus 3 square, and which should be, I think, 3.6. Yes, this comes out to be 3.61, and the angle phi is given as tangent inverse of b over a. If I do it for my numbers, tangent inverse, and my b was -3 divided by 2, and I get an angle of -56 degrees. That is my phi. But over here it is important to consider that the tangent, the angle phi, changes from quadrant to quadrant. For example, if I have numbers which are in this quadrant, my second quadrant, and I have to find phi, this angle phi, what I will do is, if we make up numbers like, for example, our Cartesian are -2 and +3, but when we run this in our calculator, tangent inverse of 3 over -2, it cannot differentiate between this and this, which was 2 over -3 over 2. So it will still give us -56 degree. If you are in second quadrant, if you are in second quadrant or third quadrant, you have to do a little adjustment. For second quadrant, you have to basically subtract pi or -180 degree, and for third quadrant you have to do this is for second quadrant, and for the third quadrant you have to do this, or plus 180. So if we have 56 degrees and we have 236 plus 180, sorry, my bad. If you are in second, if you are in second quadrant, you have to do a plus 180 if you are in degrees, or you have to do a plus pi to whatever angle that you get, and that's going to be your phi. For example, we got -56 degree, but that is not the real angle, so it's going to be -56 degree plus 180 degree. That comes out to be, if I do it over here, -56 plus 180, wait, -56 plus 180 is 124 degree. But we can do all of this right in our calculator if we can plug our quadrants. For instance, like my imaginary number, is like this. It's negative 2 plus 3 and you get an I by pressing your second and your decimal number, and I do enter. That stores that in my answer. There are multiple ways of doing it, and I'm just showing you one of the ways that I usually use. So if you want this answer in your polar coordinates, you just go press your math function, math, and scroll to the right, and then CPX, that is for the complex, and you need the seventh function, which is asking you for the polar, and then you just do equal to, and you can see right away that we get the same thing, 3.661, and the angle, that's my polar coordinates, and the angle is 123.69 degrees, so which is almost 124 degrees. This makes a whole lot easier, and you don't even have to worry about what quadrants you are in, second or third, and it's faster way when you're working with complex numbers and you have to move between Cartesian and polar back and forth. Thank you.